Hello, welcome to my Lab 4 Physics 1 presentation. And in this video, we'll be going over the introduction, the goals of the lab, the process, the outcomes, some errors, important concepts, and a wrap-up. And to start off with the introduction, in this lab, we explore the oscillatory motion of a mass spring system, focusing on a two-dimensional motion where the mass swings in an arc while oscillating. By analyzing the motion, we will be able to apply fundamental principles of oscillations and energy conservation, just as we studied previously. We use the tracker program to analyze a video of a mass spring system in motion, extracting position data to study its oscillatory behavior. After collecting data, we will use a computational modeling to simulate the motion to analyze the energy changes. Now for the goal, a good primary goal for this lab is to demonstrate and analyze the fundamental principles of energy conservation within oscillatory motion. By studying the movement of a spring mass system, we aim to understand how energy transfers between kinetic, gravitational, potential, and spring potential energy while ensuring that total energy remains conserved. Through experimental data analysis and computational modeling, we will test whether our observations align with theoretical predictions, reinforcing our understanding of oscillatory motion and energy principles. And just to kind of sum up everything I've said previously, a good overarching question would be to ask yourself, how does the energy conservation principle apply to the oscillatory motion of the spring mass system in this lab? Now, continuing on for the process, first off, we used a video analysis with the tracker software to get our position points, so we can then plug it into GlowScript, and this will give us, or using the tracker program with the X and Y positions, we plug that into a GlowScript program, and that gave us our simulation. And then finally, we will observe how that applies to Newton's laws of motion. Now, first off, for the video analysis, as you can see here with the purple lines, these are the axes, and starting at the origin, you can see this blue line extending to here, and that is the length of the spring at rest. And these red dots are each of the positions, and there should be about 100, I think. And as you can see, each position will give you a data point with these waves right here. And then these are per time and the X and Y positions. And then for the GlowScript program, continuing on, using this code right here, which basically just analyzes the oscillation and allows you to actually graph it, you can see how very similar to the previous data we were given. It is still a wave, it is the change in time, and as you can see, all stacked up on top of each other. You can see that delta E, which is, it's very hard to see, but this yellow line running along 0 is not changing. Delta K is this blue wave, and then you can see that delta U spring and delta U gravity are constantly switching. And those are just the important concepts to keep in mind there. What was correctly predicted? The conservation of energy, as we can see, it has to remain constant. The wave pattern, that also had to stay the same because the forces are oscillating. And continuing on with that, the effects of Newton's laws on the object suspended by the spring. And what was unaccounted for were some possible errors when using the tracker software. This is really just to do with the graphing. Like, we only got, I say only, 100 frames. I feel like if we had a little bit more, it could look a lot better. But either way, it was good enough data. I just think it could have looked a little better with some more data points. Now for some error, the poor video quality. I say poor just because there wasn't a whole lot of frames, and the less frames you have, the less data points you can use. And I just think with more data points, it would have looked much better overall. Maybe an incorrect initial velocity. If it wasn't perfectly 0, it would make the start of the graph not consistent. But hopefully with the 100 data points, that would have canceled out over the length or the entire experiment. And then possible spring mass may not be oscillating in a perfect 2D plane. For example, in the video, the spring mass could have bounced off the cardboard wall. And if it did that, it would have been projected towards the camera. And that would also cause a little bit of energy change. But those are minor discrepancies. Now for the force components, as you can see, the major ones to keep in mind were the conservation of energy, which is constant delta E, and the point particle system, delta UG, delta U spring, spring force, wave variation, and there's more and more, but the main ones to keep in mind are your spring force and your potential energy changes, which is spring, change in spring, and gravitational forces. And that is it. Thank you very much for watching, and have a great rest of the day.